Okay, so today is April 16th, and this is our class on predicting products. Okay, so the first thing that we're going to do is fill out this page, page 18 in our packets. And one thing that we talked about the last time when we looked at the cartoons and the dancers and things, well, not really the last time, it was a couple times ago. But we defined different reaction types as either synthesis, decomposition, single replacement, double replacement, or combustion. And on the pictures of the little cartoon characters, we had some letters there. So what we call these letter equations are general forms. So the general form for a synthesis reaction, and if you recall, if something is synthesized, it's like you're taking two things and you're bringing them together. So the general form for a synthesis reaction is A plus B yields AB. And so that is the general form for a synthesis reaction, and you guys should write that down on your packet page that corresponds to this one. A decomposition reaction means that something is falling apart. And actually, a decomposition reaction is the opposite of a synthesis reaction. So I'm going to start with my product from up above, which is AB, and it falls apart into its separate components, A plus B. And so these two are simply opposites of each other. All right, our next one is single replacement. And with single replacement, one thing replaces one other element in the reaction. So with a single replacement reaction, we have A plus BC yields B plus AC. And the thing that's happening is that the metals or the halogens switch. So A and B are usually going to be metals, but sometimes if A is a halogen, then it's going to switch out with the other halogen. Can anybody name a halogen for me? Yeah, good. Fluorine, and then any of those other elements that are found in the same column. So fluorine, chlorine, iodine, bromine, all of those are halogens. Thanks. Was that Dana? If it sounded like Dana. Okay, then let's move on to double replacement. In double replacement, we start off with two compounds as our reactants. So we have A, B plus C, D. And what's going to happen again is our metals are going to switch places. And remember that the metals are always listed first. So A and C are going to swap dance partners, so to speak. What we get is CB plus AD. And so once again, metals switch. Okay, and then lastly, we have combustion. And combustion is going to use a hydrocarbon and we're going to add some oxygen to it. And when we do that, we get the same products all the time. We get carbon dioxide and water. So this is the way you need to know these general forms in order to begin the process of predicting products. So I'm going to scroll this up a little bit because down here for numbers 2 through 7, I am giving you the steps that you need to take in order to predict the products of a reaction. So I'm going to give you the reactants, and then you have to tell me what the products are. Like, what are we going to get on the right-hand side of the arrow? Just remember one super important thing, and that is this, that ionic compounds need to have a total charge of 0, and that's what we practiced the last time, and on that Kahoot quiz that you guys did was just figuring out what the formulas and the names of these ionic compounds are. And then your final thing that you have to do is balance the equations. So let's go through a couple of these problems. But look at number 8. Before we begin, what is a hydrocarbon? Can somebody please unmute and tell me what a hydrocarbon is? Or what's in a hydrocarbon? Yep, it is a compound that consists of only hydrogen and carbon. I'm going to tell you, though, that sometimes you can have some oxygen in there, too. So it could be C and H for sure, sometimes oxygen. All right, I'll give you a minute to finish writing that out. All right, does anybody need me to pause or to move back up, move the page back up so that you can see something before I move on? Okay, right, then here we go. All right, so let's look at our very first equation. So like I said, I gave you the reactants, and you have to tell me what the reactants are going to make. So the first thing that I need to do whenever I'm predicting products is I need to decide what kind of reaction am I looking at here. To start, I'm going to assign a letter A, B, C, or D to each element that I have in my reaction. So here I have hydrogen, and since that's my first one, I'm just going to say that hydrogen is A. I have my plus sign, and then I have chlorine. And since that's a different element from hydrogen, I'm going to give that a different letter, which is a B. So what I need to do next is scroll back to my chart, and I have to decide what kind of equation it is. Which of these reaction types has A plus B as the reactants? Correct. So what that means is that my product is going to be AB. All right, keep that in your memory for just a moment while I scroll back down. So above my equation here, I'm going to write A, B. So there, I just did the first couple of steps in predicting products. But now what I have to do is right below my variables, I have to figure out, like, do my little substitution here. So A is hydrogen and B was chlorine. Now I want you to notice something because this is very, very important. Notice that I did not carry over my subscript of 2. Subscripts do not carry over unless they're a part of the polyatomic ion. And I'll show you in a little bit what I mean by that. So now I've got my final product here, HCl. But now what I have to do is make sure that my charges are balanced. So if you look at your chem helper, we need to find hydrogen, and hydrogen is here and it has a charge of +1, while chlorine is over at the other side and it has a charge of -1, which basically means that 1 hydrogen and 1 chlorine are going to cancel each other out. So I don't need to add any subscripts here in order for my compound to have a total charge of 0. Now I'm on to my last part. Now I have to balance my equation. So I'm going to draw my line underneath my arrow. On my reactant side, I have 1 hydrogen and I have 2 chlorines. And on my product side, I have 1 hydrogen and I have 1 chlorine. And that's an equal sign, not a 2. It looked like a 2. In order for me to get the right amount of hydrogens and I'm going to look at chlorines first because that's the one that's imbalanced. I need to put a coefficient of 2 in front of HCl, and that changes my letters here to 2. Oh my gosh, I just realized. Hey guys, on your sheet, you have to add something. I have a typo here and I didn't even realize it. This shouldn't be just H. This needs to be H2. That's my fault. Oh gosh, I'm so sorry. So that's going to change my balancing here. So my H is actually 2. Okay, now I'm balanced. Now I'm fine. Oh my gosh, that was a big mistake. I apologize. So, but now we're fine. Now we're balanced. And on this line here, we said that this was a synthesis reaction. All right, so that was a lot of stuff in one thing. Let me pause for a moment and ask you, do you have any questions? You might not yet, which is fine. All right, let's do another problem together. Let's look at letter B. For letter B, I have a compound C2H6, and I'm adding oxygen to it. What do you notice about my compound C2H6? It's a special one. It's a hydrocarbon. What kind of equation begins with hydrocarbon and oxygen all the time? Yep. So here's my combustion reaction right here, a hydrocarbon plus oxygen. And combustion reactions are kind of simpler than all the others because the products are always the same. You always have carbon dioxide and water as your product. So this is a combustion reaction. And I don't need to use like A, B, C, D letters here. All I need to do is write CO2 plus H2O. But now what I have to do is make sure that my equation is balanced. I can tell just from looking at my carbons, because I've got 2 on the reactant side and I have only 1 on the product side, that this is not a balanced equation, so I need to balance it. Now, with combustion reactions, balancing